Now in question 11, we are given a diagram as well as 4 lines, and we are told that the 4 lines on the diagram shows parts of 4 paths of a spacecraft moving near the Earth above any influence of the atmosphere. So this simply means that there is no air resistance. So which path is not possible unless the spacecraft fires its rocket as it follows the path? Now, let's deal with the obvious one first. For option A, the spacecraft does not have to fire the rocket or essentially exert an external force, because if let's say we have the rocket over here, gravity will naturally pull it down. Now, for option D as well, similarly, if we launch the object from the ground initially, after giving it an initial push, we turn off the rocket, the spacecraft will be able to ascend all the way upwards before finally reaching its maximum height before falling down. So this is very simply the case of gravitational deceleration. For option B, this simply reflects a spacecraft that could be in orbit. And when the spacecraft is in orbit, we know that the weight can supply the centripetal force. And since the weight is exerting all the force, we do not need any additional forces to keep this guy in orbit. So the odd one out and our answer is going to be option C. Now, to understand why this cannot be correct, if the rocket were at this position, you will experience a gravitational force this way. In order to keep him moving along this direction, basically, the rocket must fire towards the right in order to cancel off the horizontal component due to the weight. This will leave only the vertical component of the weight that will allow the rocket to move forward in a straight line. And the same can be said for any other point along this line.